Ever thought about where the water in your glass comes from? It might surprise you, but that exact same water has been on Earth for a long time. It is the very same water dinosaurs drank millions of years ago. To understand how that's possible, think of Earth's atmosphere as a giant planetary kitchen, and the head chef running the whole operation is the sun. The sun's main tool is heat. In this diagram, we can see exactly how it works. As the sun warms up oceans and lakes, it turns liquid water into an invisible gas called water vapor, which rises straight up into the air. We call this upward journey evaporation. As that warm vapor travels higher into the sky, it enters colder air. You can see the vapor turning blue as it cools down, causing it to clump tightly together into tiny, microscopic liquid droplets. These clusters are clouds, and that clumping process is condensation. Inside that cloud, the tiny droplets bump into one another. They join together, growing bigger and darker until they are completely full. Once they become too heavy for the air to hold them up, they fall back down to the ground as rain or snow. That return trip is precipitation. Because of this, water never really leaves. Every drop is caught in this continuous, sun-powered loop, traveling from the ground to the sky and back again, over and over. But the water cycle is only one part of the story. The daily changes in our weather depend entirely on how our sun mixes different air masses, specifically how warm, wet air interacts with cold, dry air. These atmospheric ingredients change throughout the year because the sun doesn't heat the planet evenly. Depending on the month, the intensity of the sun's heat shifts across different parts of the globe, creating our seasons. During the winter months, the atmospheric stove is effectively turned down to a low simmer. The air gets incredibly cold, freezing the moisture and giving us snow, frost, and sleet. Then, summer rolls around. The stove gets cranked up to high heat. That intense warmth pulls massive amounts of moisture out of the ground through evaporation, leaving the air feeling hot and incredibly sticky. Whether you are bundled up in a heavy coat or sweating in a t-shirt, the temperature of the atmosphere is the master variable deciding what kind of weather gets served. To predict what the atmosphere is cooking up next, we can look to the clouds. These are massive structures made entirely of water droplets and tiny ice crystals. In this photograph, we can see the classic fair weather clouds. Notice the distinct flat base and the bright white, towering, fluffy top. These are cumulus clouds, and they usually mean you are in for a lovely day. But if we look at this next picture, the shape is different. These thin, wispy streaks stretching across the blue sky are called cirrus clouds. They float incredibly high up, are made mostly of ice crystals, and usually signal that a change in the weather is right around the corner. Then there are days that look like this photograph. See how the sky is covered in a uniform, featureless gray blanket? These are known as stratus clouds. They block out the sun and tend to bring long, gloomy days filled with drizzle. And finally, we have the king of the sky captured in this image. Look at its immense vertical growth and flattened anvil-like shape. This is a cumulonimbus cloud. Its massive, towering size means that heavy rain and incredibly strong, violent winds are brewing. By learning to recognize these distinct shapes, you can look at the sky and get a reliable preview of the atmosphere's next move. Massive cumulonimbus clouds form when a warm, wet air mass crashes forcefully into a cold, dry air mass. This collision makes the atmosphere highly unstable and sets the stage for a storm. Inside one of these dark storm clouds, violent winds are rushing up and down. It acts like a giant blender, constantly smashing millions of frozen raindrops and ice crystals into one another. In this cross-section diagram, we can see what all that crashing does. The constant friction creates static electricity. Positive charges get pushed to the top of the cloud, while negative charges pool at the very bottom, building up incredible tension. Eventually, that electrical charge gets too intense to hold. In this photograph, you can see how the cloud releases that tension. It shoots a massive, jagged spark of electricity straight down to the ground. That is a lightning strike. The moment that bolt flashes through the sky, it superheats the air around it in a fraction of a second. This sudden, extreme burst of heat forces the air to violently expand outward. That rapid expansion acts like a physical blow to the atmosphere. It creates a massive, invisible shockwave that ripples through the air, which our ears catch as the loud, booming rumble of thunder. You might wonder why the flash and the boom don't happen at the exact same time. As this animated race clearly shows, light is incredibly fast, while the sound wave jogs far behind. Because light moves faster than sound, you will always see the lightning flash seconds before you hear the resulting boom. So the next time you watch a thunderstorm, you'll know you are really watching a giant atmospheric battery forcefully emptying out its stored-up electricity and pressure. Sometimes the conditions in the atmosphere create something even more intense. If winds at different heights are blowing at completely different speeds, the air in between them starts to roll, creating an invisible, horizontally spinning tube of wind. If a powerful upward draft from a thunderstorm grabs that rolling air, it tilts it straight up. In this photograph, that vertical tilt creates a violent, fiercely spinning funnel column that connects the dark storm cloud directly to the ground, a tornado. If we move away from dry land and head toward the warm tropical ocean waters near the equator, extreme heat fuels an entirely different kind of spinning system, the cyclone. As we look down from space in this image, we can see the scale of it. Massive amounts of warm ocean water evaporate and rise, spinning into giant bands of thick cloud and heavy rain that violently swirl around a totally calm, clear center known as the eye. Whether it is a tight funnel over land or a massive swirl over the ocean, these spinning weather patterns are how the Earth balances out extreme pockets of heat and moisture. From a gentle, sunny afternoon to the most intense swirling storm, every piece of weather we experience comes from the exact same process, our planet constantly mixing air, water, and heat from the sun. Because the water cycle operates in a closed, infinite loop, the Earth never loses any of it. It simply moves that ancient dinosaur drinking water from the high clouds down to the ground and back up again. It is an incredibly energetic system. For example, during a severe storm, a single bolt of lightning flashes with so much energy that it is actually hotter than the surface of the sun. This powerful, energetic machine is constantly moving and recycling, quietly keeping our entire planet alive.